Hello everyone, good morning. So in previous video, I explained about the connectivity in terms of submarine cables. In this video, I will talk about switch. So how switch works. So these are the 10 modules and I will explain one by one. What are these? Switch, router, firewalls, IDS, IPS, DNS, proxy, WAF, load balancer, endpoint, access point. So I will not go into details because if I go, I'm just making this video for the general students which are in college. You can understand what are these devices. You should know what are these devices. Once you get the chance to work on these, you'll find out. You'll find out. You'll explore and you can learn. Otherwise, I'll be making one another video for the each modules with the help of example configuration, how to configure it, and go into the depth. But for now, I am going to explain just about the node, how it functions, what are the works it perform to have the communication smoothly in the network. So first model is the switch. This is the one sample diagram I have drawn here. You can understand like there are two office 1, office 2, router, and office 1 has this architecture of a connectivity of a devices, how these are connected. This is the flow of devices. This is the internet. You talk about, internet. Internet is a nothing but interconnected system of all on the earth. Any system which is not connected to the internet, that is a standalone system. Your device, if you on mobile system, if you turn on your internet, your data, you're connected to the internet. Anyone, if something or somewhat, if your system is connected to the internet, it is prone to the risk of a cyber attack. There are multiple cyber attackers continuously identifying vulnerability to exploit systems connected to the internet or the private network somehow. Private network are also connected to the internet. Somehow they are connected because of their business, because of their requirement. Somehow they are connected. So I will explain the diagram how nodes are interconnected to have the communication. So for example, we have a objective to get the communication between office 2 and office 1. So this is how nodes are connected. First is a router where your internet connectivity terminates, and then firewall. Firewall checks for the traffic filtering, and based on the requirement, you can allow, you can block what services you want to allow to your users to have the communication to over the internet. Core core switch is the like the L3 devices which works as L2 and L3 devices. And distribution switch is distributes all the access switch like multiple building. If you have a large office like and you have some resource at the floor 1 and floor 2, so you can distribute the switch by connecting to the access switch, and then under this access switch are connected, and access switch distribute all the endpoint systems. So all your endpoint system, laptop, Wi-Fi, access points, servers are connecting to this access switch, and then you can have the connectivity. So these are the access points. Access points are nothing but to extend your network via wirelessly, and you broadcast your network. Users can have the connectivity via cable itself, directly connecting to the network, or via Wi-Fi. It will be same to have the communication, and the office too, same architecture is also here. And one more thing, these connectivity like office 1, office 2, it's a traditional communication on the like on-prem connectivity. And Nowadays, the uh, organizations, companies are migrating their resource from on-prem to cloud to have there all the offices. For example, any company having the offices across the globe, like in multiple countries. So, and they have their resource, their application hosted at a multiple location. So, and in terms of a connectivity, in terms of a physical connectivity, if something happens, they won't be able to connect to their business, or business cannot function properly. So, to get the centralization, so all the resource they can get and host onto the cloud infra. There are multiple cloud services: AWS, Azure Cloud, and multiple other Microsoft Azure Cloud, and Oracle Cloud. There are multiple cloud service provider. You can have the subscription. You can migrate your on-prem services to the cloud. They will help you completely from your office to migrate to the cloud securely. So once you migrate, your connectivity will divert. You can have the private connectivity from direct cloud to your uh, office, and you can manage your services over the cloud. So theoretically, I'm going to very deep. So WAF, the WAF I have mentioned, you can deploy over the cloud. For the application filtering, like WAF is the for application protection, load balancer is for, I will explain it. What are these used for? First of all, we should go for switch only. So this is switch. So how switch works? Like switch, you can consider that one office switch. There are 50 users, and you can connect all the 50 users with using one switch, and multiple vendor switches are there. Vendor switches are there. Multiple ports are there. Variety you can get. So for example, 48 ports. So if you have a 50 users, so you can use 48 port switch, or two switch you can use, and the both switch you can connect, and user can connect to it. So all the systems connecting to it have a MAC address, physical address we say. So the MAC address is a 48-bit 6 octet in hexadecimal format. So it's like I will quote one example here: 98, 98 AB, BE, 6E, 12, DF. So one one is a 4-bit, second is a 4-bit. So first octet, second octet, third octet, fourth octet, fifth, sixth, 6 octet. Octet in the sense 8-bit. 8-bit. One octet is equals to 8-bit. Leave it. So all the system have this address, physical address. Based on this physical address, switch perform the connectivity between your systems. 50 users can communicate to each other based on their physical address. So like for this endpoints, physical address would be something like this. And for second PC, one MAC address would be like this, but different. So switch works. First of all, when a switch is powered on, it will populate its MAC address table. So like if it broadcast all that once, for example, this system wants to have the communication with this system, so it will send a one message will send. Switch will get this message on this port. So it will like broadcast a message to everyone, all the 50 users connecting to this. So and it will say, see, this is the packet I have received. On the switch level, be represent packet as a frame. this frame I have received from this port, and this person wants to have the communication with this. So this person will mention the destination MAC address. It works as a source MAC address. In a pack, in a frame, it will be mentioned, and destination MAC address. So it will switch will not know who is that destination MAC address, who is that person. So switch will try to find out, and it will broadcast, it will send that message to every port, every user connecting to the network. It is initial phase when MAC address convergence or MAC address table forming is in the process. So everyone will receive it, will discard it. No, I'm not that this MAC address is not mine. So the person who is of that MAC address will respond, this is my MAC address, here my address, take it. Switch will get the switch will first note down this MAC address as a source, that this person is connected to me on this port. So it will form a MAC table, MAC and port. So for first person, it found out MAC and port. Second person, when it gets the message, everyone will discard, no one will send. This message will receive from a switch. Switch again note down MAC2 and this his port detail P2. So now two addresses are there. So likewise, if one user from these users wants to have the communication, it will send, same process happen, and in such a form MAC table gets formed. So once the full MAC address is formed, switches performance will increase, delay will decrease. Initially, some delay will you will face, but after that, once a MAC address table is formed, delay gets really decreased. So this is how switch works. Switch is a L2 node. You can in initial L2 node in the sense like here. So it works on a OSI model. There are 7 layers: L1, L2, L3, L4, L5, L6, L7. So initial, this is the application level. Like you open some application on your laptop or your mobile, you type a message, then message gets at the transport layer. Transport layer in the sense like it gets and then from transport layer it gets to the network layer. Network layer is nothing but the like router, firewall, and then upper levels. And data layer is the L2. L2 is the switch where your other users is connected, and then it again unpacked and then received on the physical layer is nothing but your cabling, your system, these all comes under the physical layer. And one more uh, updated model been published, that is a TCP IP model. It's a 4-layer model. All these applications have been submerged into the one layer, that is called application layer, transport layer, network layer. These two layers have been network access layer. Data layer and physical layer have been merged into the network access layer, but this is the generally people follow for their communication or for their knowledge. So you can have this note down. Yeah, so which I have explained, I will wrap up once again. Switch is a L2 devices deployed. If we talk about in terms of SI model, L2 we refers that layer 2, and responsible for the switching the frame from one host to other. It mostly used for the local communication like a single office or home network. You can connect to that. If you like this switch is like whatever I have explained, this is feasible for when you not having internet connectivity, that local connectivity, only your 50 users wants to have the communication with each other, but not the internet. Once internet connectivity is required, you have to have this whole architecture. You have to have firewall is needed to secure a network. So that's all. In the next module, I will talk about the router, how router works, and how switch and routers communicate with each other. Thank you all.